This is a test recording of my AQA computer science non-exam assessment 2023. I've chosen the title or problem Pathfinder Visualizer with maze generator from Wall. So here's my code. When you run the program, everything runs, and off the bat the program works pretty well. One of my aims will, oh, I should probably have my aims up. Yes. If I kick off with my aims initially, and then I will get to the general testing of the program. So one of my aims was to create a window that visually shows a grid on the screen, and I feel that just by running the program, you can clearly see that I've achieved that aim. Next aim, the grid will be of appropriate size. I feel this window is not too large, not too big. If it was too big, the program might take too long to run, but I feel like it's appropriate size. It doesn't take, even if I have the target node way up in the corner here, it doesn't take too long to run, so I feel like I've achieved that aim. The grid must display a start and end node. So upon running the program, you can see that the program displays a start node here, denoted here by the how to use section, light blue node start node. But the end node, which will be a yellow node, will be right-clicked, but will be placed by the user wherever they wish to place a target node. So testing that, you can see if I right-click on the board somewhere, I can drag this wherever I want it to be. So I feel like, so that aim of displaying start and end node is achieved. And then the next aim, the user must be able to move the start and end nodes around. Well, as demonstrated, the end nodes here can be moved around. However, I was unable to code a solution to being able to move the start node around. This will be mentioned more in the evaluation section of my project. Next, aim number 2. You're to generate a maze around the start node and end node. So up here you can see I have these buttons. I have a how to use. I'll just quickly demonstrate. I have a how to use button here, which tells the user how to use the program. So right click to place walls, place or move target node. Left click to draw walls. User buttons at the top. It's pretty self-explanatory buttons. And then just a note that these two buttons here, generate maze and randomize walls, will not work at the same time, as I don't feel that there would be any beneficial reason for these to be used at the same time. Therefore, I just made them not able to be used at the same time. And then I have a key here for what the different node colors means, so that you know what's happening, and it's pretty clearly denoted what each node means. So light blue node start node, yellow node end node, black node wall node, green node visited node, red node queued node, and a dark blue node path node. So back to the aims. To be able to generate a maze around the start and end node. So as we can see here, the generate maze button, which if we press, generates a maze. And if I do this a couple times, placing down a start node end node each time, you can see that at no point do any of the maze walls coincide with the start node or end node. No matter how many times I do this, the start node and end node are always path to, and they're always pathable to, and they're never inside a wall. So there's always a path to the from the start node to the end node. The next aim, the user must be able to generate a new maze at will. As you can see, there is a clear grid button, which does what it pretty much says on the tin. It clears the current grid state and lets you generate a new maze at will. And if I just pause for a second, you can see that each maze is different each time, and it's not just the same maze being generated at the same time. I'll do this a couple more times for demonstration. You can see that the mazes are different each time. Next aim, the maze must always be solvable. I can run it a few times and the maze will always be solvable. Yeah, the maze. This aim is achieved. Well, I didn't generate a maze that time, but yeah, I've run this probably hundreds of times, and every time the maze was always solvable. Unless I draw my own walls, that different issue. But if I just generate maze, then you can see it's always solvable. I can generate a maze that time. Next thing, the user must be able to clear the board. Pretty self-explanatory here. I am able to clear the board no matter what's on the board. If I randomize walls and then visualize Dijkstra's, I can clear the grid. If I draw my own walls and then randomize walls and then visualize Dijkstra's, I can clear the grid. If there's no solution, I can clear the grid. So regardless of the grid state, I will always be able to clear the grid. 2. To allow the user to be able to draw their own walls, as already demonstrated, this aim has been achieved. I'm able to draw my own walls by left clicking and dragging on the grid here, and I can delete walls by holding right click and dragging the target node over. The user must be able to clear the board. I think I read these in the wrong. Oh no, I'm reading the wrong aim. Sorry about that. In the case of an unsolvable grid where the algorithm cannot find the end node, a message will display on the screen stating so. I think I've demonstrated one of these already, but if the path finding cannot path to the end node, a message will pop up on screen stating that there is no solution. That was I should probably do something like this so it's more clear. There's no solution. I can clear the path and try this maze state again. There's no solution. I could clear the grid, make a new maze state with no solution, and there's still no solution. I get an error message every time. 4. At the press of a button, the user can visualize how a pathfinding algorithm finds an end node given a start node. As demonstrated already a couple times in this demonstration, this algorithm, my code does just that. It takes start node, light blue node here, and when you place a end node, it's yellow node. When you press visualize Dijkstra's, you can visualize how Dijkstra's looks for this target node and then the shortest path to this target node. 4.1 to implement Dijkstra's pathfinding algorithm. Yeah, that aim was achieved. 4.2 to implement other pathfinding algorithms such as A star or depth first or breadth first to distinguish between them from Dijkstra's and each other. This aim was not achieved as I feel like in this context with no weighted walls, Dijkstra's and breadth first search are almost indistinguishable. Depth first search I used to generate my maze, and A star search. This will be mentioned more. This aim was not achieved. I've only implemented Dijkstra's. So this aim was not achieved, but that will be mentioned more in the evaluation section. 4.3 to visually show which nodes are being visited in real time. So if I just run the program, you can see that the red nodes are the nodes that are being visited, and the green nodes are the ones that have been visited. So the next aim was I should do these in the same vein. To visually show which nodes are being visited in real time, and the next aim was to visually show which nodes have been visited in real time. But as we can see, if I run the program, you can see that these red nodes are the ones that are being visited, and the green nodes are the ones that have been visited already. So after they turn red, they will go green, showing that they have been visited. The next aim was to visually show the shortest path between the start and end nodes, which again, having demonstrated this a few times, you can see that after running the visualize Dijkstra's button and it path finds to the node, you can see that the shortest path to the node is found regardless of where the node is on the screen, whether it be the right hand side, left hand side, or below it, or even if there's a massive wall in the way, it will always path find to the end node. And aim 5 was to create a fun and engaging program that is also educational, and this aim will be addressed in the evaluation section of my NEA. So now just a general overview of, I'm going to go a bit more into depth about some things that I added, some error handling that I've had to implement to ensure that this program is robust and doesn't break down. For example, while Dijkstra's is running, I'm not able to place walls. I'm not able to move the. I'm not able. Oops. Sorry, bear with me for a second. While Visualize Dijkstra's running, I'm not able to move the target node. I'm not able to draw walls. I am not able to generate a maze. I'm not able to generate any randomized walls. So once Dijkstra's is running, it will solve that maze state. It will solve this maze state until. Sorry, excuse me. It will solve this maze state unless you clear the grid, of course. You can't draw or move, so it will solve this maze state unless you clear the grid, obviously. Another thing that I've implemented is that you're not able to generate walls you're not able to generate a maze and use randomized walls at the same time, as I feel there would be no benefit to having these run in conjunction, as oftentimes if I generate a maze and do some random walls, oftentimes that would result in unsolvable maze state. For example, now there's no solution, as there are random walls stopping the maze from being solvable. So regardless of if you try to generate a maze and then randomize walls, you get an error message. In the same vein, if you randomize walls and try to generate a maze, you get an error message. That's a feature I don't think I've spoken about yet. Randomize walls. I'll pause every time I do it, so you can see that it does in fact just place some random walls across the whole board, and then you can visualize Dijkstra's. I think that's pretty much everything. I can edit this out if need to be. But okay. If I visualize Dijkstra's and if I want to solve this exact same maze state, I can press clear path, and the maze state is still it's the exact same maze state. I can move the target node, draw extra walls. This was a feature that was recommended. This was a feature that I only recently implemented. It was a feature that was recommended with me after having spoken to my third party, after they generated a maze and they solved the maze and they wished to move the target node around this same maze, but they weren't able to do that because the only button I had previously was clear grid. I then implemented a clear path, which keeps the same maze state. As you can see, this maze state hasn't changed. If I just press clear path, only the path and visited nodes are removed. You can move the target node and visualize what this maze looks like if the target node's here or in this corner, for example. Yeah. Oh, another feature I've implemented is the ability to only generate one maze at a time. As again, I don't feel there would be any benefit to being able to generate multiple mazes on top of each other, as if I demonstrate with randomized walls, this would eventually just end up in every square being a wall node. Obviously, there being no solution here. I've allowed it with randomized walls so that you can get as random as you want. Obviously, at a certain stage, it will become unsolvable, but that's up to the user to randomize walls. You cannot clear a path if there's no path. Pressing clear grid when the grid is empty doesn't break anything. Everything still works. I can clear empty grid. I can clear just target node. I can clear just walls. I can clear target node and walls. And as I've probably demonstrated, you can clear everything and get back to a blank grid. Pressing clear path, again, only clears if there's a path. If there's no path, as for example now, you'll get an error message saying visualize Dijkstra's to get a path. Yeah, you can't. Oops, sorry, excuse me. Yeah, you can't generate a maze or randomize. We can't add walls once the program is running, and the program doesn't run if there's an error message. So the error message popped up. I've clicked off it. I can't access anything. I've clicked off it. Sorry, excuse me. I can't access any of these buttons. I have to clear that error message before I'm able to use it again. So that's my NEA for 2023. Hope you liked it, and yeah, goodbye.